So in the today's agenda, we'll be talking about regression analysis. What is regression analysis? Then we'll be talking about simple linear regression. Okay, how you can evaluate the model and how we can select the model by using the different model evaluation matrices. Okay, then we'll be talking about multiple linear regression. We'll see the what is the difference between multiple linear regression as and the simple linear regression. Okay, then we'll be talking about the regularization techniques such as ridge regression and lasso regression, and we also talk about the why we are using this ridge and lasso regression. And after that, finally, okay, last but not least, we'll be talking about model evaluation matrices like R square, mean square error, mean absolute error, as well as we have the RMSE, as well as we have the different evaluation matrices that we are gonna discuss in the last when we are dealing with the model evaluation criteria. Okay, sounds good, guys. So, guys, okay, I'm giving you one suggestion. Okay, along with those codes, you can start exploring the deeper into that particular topic. Okay, as we said in the previous sessions, okay, we took the two previous session, and in those two session, okay, we were talking about the basics of Python, right? So we started with the different data types of Python. Okay, then we just started with the the different how you can create data frame in Python by using pandas library, and how you can use a NumPy library in that. And one more thing, guys, this is the beginning of machine learning algorithm, because if you understand the machine learning, so you will find that in the machine learning, okay, machine learning is nothing but we are trying to automate the machine works. Okay, like we are trying to say that, okay, like if machine is not able to do the the work like humans, okay, so or in short the automation, so we are just by providing the data, we are saying to the machine that this is the data. Now we just created the model, and that model suggests the machine, now you can do this thing, now you can do this thing, right? So over here you can see that, okay, first topic is nothing but the regression analysis. So regression analysis, you will see that there is one topic in machine learning, okay, and you will find that that topic, okay, particular topic is nothing but the prediction of numerical data. So what is prediction of numerical data? In that you will have to build the models of regression, okay, and that is also nothing but a regression problem, right? So that is what we are gonna see in the today's session. Okay, so guys, let us go ahead and understand how the regression works. So for that we need to understand the scatter plot. Let me show you that thing. Okay, if you know, so I already shared this thing with you. Now see, yesterday, okay, what we did, I show you this particular scatter plot. Not this, we also showed you this multiple scatter plot. Let me show you again. Okay, so you can understand. Import pandas for that as PD, right? Let me go and run this. Okay, this is how the data looks like. Okay, and now instead of this, let me use the population. Okay, life expectancy versus population. Let me run this, and here you go. Let's understood this. Okay, let's understand this, how you can build the how you can get the scatter plot from this. So as yesterday, as I discussed with you, so here you can see this is nothing but the one of the scatter plot. Okay, the data is totally random, that's why you can see that the few data is a lot of data merge over here, okay, concentrate over here, right? And the only few data is look like this. Okay, now let me show you the data which will be using in the today's session. Okay, okay, leave this particular by saving this particular file, and let us go with our today's code. Okay, this is not the code, this is the data that we are gonna use. Okay, let me create the one Jupyter notebook file over here. because I'll show you the how you can read the data, how you can do all the things with the data from scratch. That's why, okay, I just created the new notebook over here. Let's say this is a day 3. Okay, and in the day 3 we will be talking about the regression analysis, right? Now guys, here you can see, like as I showed you the scatter plot, which is totally different because that is coming from a real life data set. So here as well you can see that if you are creating a scatter plot, okay, so okay, how many variables we need to create the scatter plot? First, there are two variables you will need to create a scatter plot. First variable you can plot on the either x or y coordinate, and second variable you can put on the again either x or y coordinate. So here this is my variable a, this is my variable b, okay, and you will see that the data set like this. Okay, these dots are nothing but the data points. Okay, these dots are nothing but the data points. Okay, now here you can see that, okay, I mentioned the points over here, and you will always find that, okay, when you are dealing with the real life data set, so here you will find that the outliers m- you know may present in your data set. Okay, now as I told you in the previous session, what is outlier? Outlier are nothing but the extreme values. Okay, and what is extreme value? Let's say you have the data from 1 to 100. Okay, and in that particular data, okay, there is one or two or few values are more than, let's say, 200. Okay, few values are nothing but the 200. Normal range of your data is 1 to 100, but there are only few values, let's say 4 or 5 values are there, and those values are are nothing but the 200. Okay, like the 200, 201, 202, like this. Okay, so those values are nothing but the outliers. Okay, those value are nothing but the outlier in one dimension. Now here you can see in this particular data, here you can see, okay, see, this is my data point, this is my first data point. Here you can see, and the x coordinate value of this particular data point is nothing but around 1.5, right? And for this as well, this is also 1.5, right? But for this outlier, this particular data point, here you can see the x coordinates value is going to be, let's say, 1.5, but for y coordinate you will see that the value is around 12. Okay, which means that this data is an outlier. Okay, for this particular normal range data set. Okay, this is a normal range, I would say. Okay, common range, and this is nothing but the outlier value. Okay, that is how you can detect the outliers. Okay, now here you can see, okay, I just draw the line, okay, in between the data. Okay, and that line is nothing but the line of best fit. Why I'm telling you this line of best fit? Because here you can see that this line is exactly going from the middle of these data points. That's why, okay, I showing you this particular line is nothing but the line of best fit. Okay, line of best fit. Okay, now let's move to the different types of the scatter plot. Okay, let's understand what are the different types are there of the scatter plot. Okay, as you show over here, okay, as you see over here, okay, how many different types are there of scatter plot? You will find that, okay, this first type is there. Okay, you can say that this is nothing but the positive correlation between your variable x and variable y, or variable a or variable b in short. Okay, so how you can identify this is positive correlation? Okay, there is some positive correlation between your both variable x and y. Okay, because here you can see as x values are increasing, in the same way y values are also increasing. That's why you will see that the it is these data points are making 45 degree of angle. Okay, okay, of the, okay, with the x coordinate as well as the y coordinate. Okay, so I can show you that, okay, this particular data points showing a positive correlation, because as x increases, y also increases, right? Now second thing is that the if the x values are increasing but y values are decreasing, that's why you can say that this is going to be the negative correlation, or you can simply say the trend of the data points are in the downward direction. That's why you can say this is nothing but the negative correlation between the variable x and variable y. Understood? Okay. Now here, this is the third type which I am saying you, which is nothing but the null correlation, which means there is no correlation. Okay. If your data points are showing a parallel correlation or parallel relationship between your, okay, with the x coordinate, so you can simply say there is no correlationship. Okay, which means that as x values are increasing but y values are constant. Okay, if you draw the line in the exactly middle of this particular data point, so you can see that this particular line will be, okay, very much parallel to this particular x coordinate. Yeah, will be like, I'm coming to this particular correlation. Okay, so firstly understand this particular topic. Okay, then we'll move to the correlation one. Okay, here you can see, okay, the positive correlation is there, negative correlation is there, and no correlation is there. Okay, if now the second thing, okay, second way to see the data, if your data points will, showing a exact, straight line, either upward trend, either downward trend. Okay, but it will show you the straight line. Okay, the pattern for your data points will be in a straight line, so you can say that your data follows a linearity, or your data is linear in short. Okay, if your data showing some non-linear, visuals, so you can say that, okay, if your data looks like this, okay, so this is nothing but the exponential. Okay, so sometimes if you draw the plot of e raised to x, okay, if you draw the plot of e raised to x and x values are nothing but 1 2 3 4 5 6 up to so on, right? So you draw this e raised to x plot, then your plot looks like this, e raised to x, okay, like this. See, like this. So this is nothing but the exponential. Okay, if your data point showing a non-linear curve also, you can say that the this shape or u-shaped curve, so you can simply say it is a u-shaped curve it is showing. Okay, now when we are talking about the linear correlation or linear relationship, okay, at that time we'll be talking about the correlation term. Okay, correlation is totally depends on the linearity of your data, right? If there is a positive relationship, or the if your data point showing a upward trend like this, so I can say that the data points, okay, are nothing but the positive correlated, right? If your data point showing a downward relationship in a linear manner, then I can say you that these data points will be negatively correlated, right? Now these are just the type. Now what about the strength of the, how you can measure the strength of the correlation? So here if you see the structure or the pattern of your data points, okay, will be in a straight line. One also think that these data points are very much concentrated, okay, or very much close to each other, right? These data points are very much close to this other. Okay, so after, okay, if you see these data points, okay, if there are a lot of data points, so you will see that exactly, there is very few different, very less different between the data points, and they are making a straight line. Okay, they will be in a straight line, so that's why you can say that there is a strong positive correlationship. Okay, when you are saying strong positive correlationship, when your data showing a linear pattern, also the upward pattern, okay, they are going in a upward direction. So that is nothing but the strong positive correlation, right? Then what about next? So here you can see that again these data points, okay, going in a upward direction, but here you can see that the data points are very much scattered, right? These data points are very much scattered. So we can say that yes, there is a positive correlation because the data is going in a upward direction, right? But here you can see that, okay, there is a some scatterness present. So that's why you can see that this, okay, data showing a weak positive correlation. Understood? And if your data point showing no trend, okay, no pattern, at that time you can say that there is no correlationship. In simple words, there is no pattern in the data set, or you can simply say that there is no correlationship. Okay, understood? This is the simple thing. And okay, as we discuss about the scatter plot and correlation, okay, correlation is nothing but the just it is finding out the linear relationship. Okay, not just the relationship, it is finding out the linear relationship. Let's say if this is the, if I am saying you this is a this is a positive correlation, so that this particular statement is not correct. This is not showing a positive correlation, it is showing a positive relationship. Okay, because here you can see that the data points are going in a non-linear pattern, right, in the upward trend, but they are showing a non-linear pattern. So I can say you that this is just the relationship, not the correlation. Correlation is there when there is a linear relationship. Okay, when there is a linear relationship. And guys, why I'm using this concentrated words, okay, the linear, the correlation, because you will see that in the regression analysis there is one algorithm which is nothing but the simple linear regression. Okay, in the word you, in this particular simple linear regression, you will find that the linear word is there. Okay, and with the help of linear, so you will find that there are multiple assumptions of regression analysis are there. Okay, there are multiple assumptions of regression analysis are there. So how many different assumptions are there? Let me show you. Let us talk about the assumptions of regression analysis, or in the I am mentioning this particular term over here, the, let's say, linear regression. Why linear regression? When if you are assuming that there is a linear relationship, then only you can go with those assumptions, otherwise these assumptions will not be valid. Okay, okay, let me correct yourself. There are total four assumptions. Okay, starting with, okay, if you try to remember this, there is a trick to remember the assumption by using this particular the word which is nothing but the line. Okay, when I'm completing my master degree, my teachers used to tell us this particular word to remember or memorize the assumptions of regression analysis, which is nothing but linear regression analysis. So first one is L. Okay, L is nothing but the your model, okay, is showing the linearity pattern. Okay, linearity pattern, like someone who mentioned, okay, like the y equal to mx plus c. So linearity pattern. So you will find that y equal to mx plus c. So what is this? This is a simple linear regression equation. Also, this equation is nothing but the equation of line. So c equal to, c is not slope. Okay, yes, c is intercept. Yes, and m equal to slope. Okay, so this is going to be the pattern. Okay, now here what I wanted to say is linearity pattern. So what is linearity pattern? Here, did you see any square or any cube, which means that there is no order, there is only one order, like m x raised to 1 is there, right? Again, if I use another equation, which is nothing but the y equal to beta naught plus beta 1 x, okay, plus epsilon. Okay, this is going to be the perfect, equation for the regression. Now why I'm saying this perfect, because this is nothing but the equation of line. Okay, this is just the equation of line. You will see that the data points are this. Okay, but in real life you will find that the the error is present. Okay, this is my data point and this is my line. So here you will find that between this, the distance between this data point and this line is nothing but the error present, right? So this particular thing is nothing but the error. So here you can see that beta naught is going to be your intercept, and secondly beta 1 is going to be the slope. Okay, now here I just wanted to tell you one thing. Okay, why I'm showing you this, guys? Okay, because if you understand this concept, then it will be very easy to understand this all equation. Okay, because this is just the simple linear regression equation. If we're talking about the multiple linear regression, so you will find that multiple linear regression equation is like this: beta naught plus beta 1 x plus beta 2 x plus up to so on. This is x2, this is x1, up to so on, plus beta n xn. Okay, this is going to be the equation of multiple linear regression. Yes. Okay, so let me repeat this again. Okay, this is a simple linear regression equal to equation y equal to beta naught plus beta 1 x plus epsilon. Why I am adding epsilon over here? Because here you can see that in the data points, okay, if you created the equation of line between these data points, so you will find that this particular data point and the distance between this line and this particular data point is, there is some distance, right? So this particular distance is nothing but your error. Okay, this particular distance is nothing but your error. Okay, so why I am saying this particular distance is error? Because with the help of regression line, what you are saying that in the future, okay, you are trying to predict the future data points. Let's say, okay, let's say this is, okay, this is the cells. Okay, this is the cells of the, let's say, month of Jan. Okay, let us assume that, okay, sales is increasing exponentially, right? Now this is the fab, this is the sales of fab. In the same way you will find that this is going to be the sales of March, and now I just wanted to predict the sales of April, right? So let's say, okay, I don't have the April's data because currently it's March, right? Because currently it's March. Now let's assume that there is a data, say March data point is there, and now, okay, like previously whole, let's say we have the 10 years of data, we have the 10 years of data, right? So we have the all months of data, okay, of previous 10 years. Okay, now by using those 10 years of data, I just wanted to make the prediction of the sales of my upcoming month, which is nothing but April month. Okay, this much data you have. Now you created the model like this. Okay, now your model, let's say y equal to beta naught. Okay, let's assume that beta naught plus beta 1 x is there. Okay, and now you just estimated na, so that's why there is no error, because you just created the model. Okay, and now this is the estimation. Okay, you know this value, you know this value. If you don't know this value, so you can simply add the error parameter. If you know this value, let's say my beta naught is 1. Okay, y equal to 1 plus 3 into x. Okay, my intercept is 1, beta 1 is 3, and this is my equation of predicting the sales of my upcoming months. What I'm doing over here, okay, again, I am, now as someone mentions, okay, for predicting the sales data, from predicting, this is nothing but the sales, okay, but for make the prediction of the sales data, we need to find out the few features for that. And what are those features? Those features are nothing but the x. Okay, let's say my marketing, okay, my marketing spend, right? Then what about next? Okay, then employees performance, okay, like that. So if your marketing spend is increasing, so which means that, okay, it will affect your sales, right? Let's say, let's take an example of Red Bull. Like Red Bull is around, like he is, like Red Bull is spending around, 45 to 50 percentage of his revenue in the marketing. That's why you will find that the sales of the Red Bull is increasing, okay, exponentially, right? So you just depending upon the some features which are there, okay, like the marketing expenses and all, okay, you now you have that, okay, you already know how, okay, how much marketing spend you are doing on in the April month, okay, so you have this data, but you don't have this, so you have to predict the sale. So you can simply use this. Let's say my marketing sales is, let's say, 2, okay, so 2 in 1,000 crores. Okay, let's say 2 in 1,000 crores. So y hat equal to 1 plus 3 into 2. Okay, so you will find that this is the thing. Okay, so your estimated value of the sales, okay, in the April month is going to be the 7. Okay, and let's say in 1,000 crore, so which means that 7,000 crores in the April month, which is the sales, and that is just the prediction. That is not the exact amount. This is just the prediction. Okay, it may be like 90% or 95% correct, right? So this is nothing but the goal of the regression. Okay, so where were we? Okay, we were talking about the assumptions of regression, right? So first assumption is going to be the linearity pattern is there, right? Then second one is nothing but the I is nothing but, this is not constant value. You will find that for each and every data set, okay, the value of beta naught and beta 1 will be changing, right? Now let us move to our assumptions of the linear regression. Okay, so second one is nothing but the I. Okay, I is nothing but the, our data, our x features. You will find that this x features, okay. Okay, so now what about next? I is nothing but the, you know our independent variables. Okay, the our variables, this variable should be independently distributed. Okay, independent variables will be there, right? Then what about next? Third one is going to be the n. Okay, now like I mentioned the epsilon over here, so which is nothing but the error. Okay, error is nothing but the distance between your original data point and your predicted data points, which means the regression line. Okay, so that particular error should follows the normality with mean 0 and your variance sigma square. So this is going to be the constant in each and every case. This will be the different. As I told you, the normal distribution is the continuous distribution in the yesterday's session. So because see guys, okay, this distribution is very much important when we are dealing with this regression analysis. Okay, right? There is one assumption for epsilon, which is nothing but the epsilon should follow the normal distribution with mean 0 and standard deviation sigma, or the variance sigma square. Okay, Now the fourth assumption is going to be the E. Okay, now E is stands for the, your error is nothing but the IID normal distribution, which means that you will find that the, this particular normal distribution, okay, there is no single error, because you will find that in between each and every data point you will find that there is a distance, right, for each and every data point. So these data points, it not just the, this error is not just the single error, okay, there are epsilon I from 1 to n, right? How, if let's suppose there are n values, n data point, that's why I from 1 to n. So you will find that the IID random variables, okay. And one more thing, as I mentioned, this is nothing but the constant, okay. Constant in each and every case will be different, okay. So E stands for, okay, this equally variance, okay. This variance is nothing but the equal for all the epsilons, okay, constant for this, right? So these are nothing but the four assumptions of the linear regression analysis, okay. So let us go ahead and understand the simple linear regression now. Okay, understood the assumptions. So let us discuss about these things. E is nothing but the error. Now what is error? Here you can see that the error term is there. Error term is nothing but the error, the E value. And what is E? So E is nothing but the distance between your original data point and your predicted data point, okay. We'll be talking about what is predicted data points when we are dealing with the practicals, okay. At that time you will understand 100%, okay. This line is not just the line, you will find that, okay, this line, okay, is just making the predictions about each and every data points over here, okay. So there is a distance between your original data points and your predicted data points, right? Here what I'm trying to say you is that, okay, if the value of your independent variable is 0, okay, so at that time what will be the value of Y, what will be the cells, okay. So cells will be the beta naught value, the initial beta naught value, I can say, or the initial value of your target variable or the cells, okay. If we're talking about, okay, the slope, now what is slope? So you can see that this is nothing but the rate of change. Now this is the rate of change of Y, rate of change of Y with respect to X, okay. As you know, if X is changing, which means that Y is also changing. So the beta naught value is nothing but the range of change of, rate of change of Y with respect to X, okay. So we'll go with the practical, then you will understand these all the things, okay. Go with our practicals and understand how you can implement the linear regression in our data set, okay. So here we will be talking about the first simple linear regression, okay. And in the simple linear regression, okay, we'll be taking one, okay. Here you will get the data set, let me show you that. So that's what I'm telling now, okay. Intercept beta naught value is showing the, that particular, the, the estimated coefficient in the regression line, which is nothing but the Y equal to beta naught plus beta 1 X, right? So beta naught is nothing but your intercept, right? So in simple linear regression, okay, I'll show you again in the practicals as well, then you will understand, okay. Here you can see that we have the two data points, okay. Two columns are nothing but, first one is nothing but the waist circumference, and second one is nothing but the AT is nothing but the adipose tissue data. Adipose tissue data is nothing but, you will find that, okay, around your waist, okay, like there will be fat for few people, not all, okay. For few you will find that the obesity, okay, or the waist, okay, at the waist you will find that the, there is fat, some fat, okay. So which means that, okay, if we go ahead, okay, and find out the, the, if we measure the waist circumference, okay, so with the help of that, can we able to predict the AT tissues, Okay, 80 tissues are nothing but the adipose tissues. Okay, so adipose tissue data is nothing but, okay, we can able to, okay, check that, okay, like depends on the, some percentage of that particular fat of the, around the waist. Okay, we can say that the, chances of the heart attack failure, right? So to avoid that, okay, we can use this particular regression model. Okay, because you will find that there is an alternative thing you can do. Okay, you, if you don't want to go with this regression, you can go with the CT scan. Okay, let's say if someone has a waist circumference, obesity problem is there, some fat is there. Okay, and like he just wanted to check the adipose tissue area. So on the basis of that 80 area, okay, doctors can able to get the, the how much chances are there, okay, of getting a, heart failure or heart attack in short, right? So there is one alternative to this, which is nothing but the CT scan. But in the CT scan, you will find that CT scan is expensive. Okay, if you use this regression model, this is free. Okay, if you create this model and if you made it, if you make the publicly available to this particular model, so this model will be free for all, right? Like if you just download, upload this model on GitHub or create one, Flask app for this or Heroku app. Okay, so those apps will be free to use, right? There is no charges for that. So okay, if you compare with the CT scan, which means that, right, it's good. Okay, second thing is that in the CT scan you will find that there is radiation. Okay, in one CT scan you will find that the radiation of equal to around, 400 to 500 x-rays. Okay, if you just go for the x-rays and if you, do your x-ray of chest x-ray, and if you go for the same and you wanted to do the CT scan of your chest, so the CT scan machine, okay, will produce the 400 or 500 times more radiation than the X-ray machine, right? Which means that there is a one again chance of, having the cancer. Okay, because with the radiation you will find that, okay, some people are facing the, cancer problem. Okay, that is again the second big issue. So if you wanna, reduce that particular issue, or you don't want to go with that particular scenario, so you can use this particular regression model. Here what I'm trying to say, that I'm trying to understanding you, like instead of doing these several alternative things, okay, you have the free and the safest option, right? So you can even go with this. Okay, and you will find that there will be a, the, 90% possibility is there for this particular predictions. Okay, let's say if someone, okay, come to me and say that my waist circumference is this much, I just wanted to find out the 80 area, adipose tissue area. So I'll simply use this particular model and I'll tell you that this is your 80 area. Okay, so this is nothing but the, without any cost, okay, he got the, the, 90% or 95% accurate result of his 80 area, right? Another one name is what, Heroku is there. Okay, you can use Heroku as well. Okay, and there are, the cloud platforms as well, which are, publicly available, but those are, the paid one, like the AWS is there. You can deploy your model over there. There is a, Azure is there, there is a GCP is there, Google Cloud Platform is there, right? So you can use these platforms as well to deploy your model, okay, with a, very less pay, right? Or simply you can use a Flask. Okay, like at the end of this particular course I'll try to show you the, the one end-to-end data science project with the deployment in the Flask app. So you will understand how you can deploy any other, machine learning model in the Flask, and you can create your own Flask app. Okay,